A, B, C, D, E, F, G, H is a cube and the edge of the cube each length is 1 unit. And P and Q are the midpoints of the two edges E, F and F, G. Now let's see what is the requirement. We need the distance of the vertex D from the plane passing through P, B and Q. As we need the distance to be from a point D, let's initiate that point D to be origin. Now if you look at the advantage of considering D as origin, as it's a cube, the three edges that passes through D must be mutually perpendicular. Then can we take one of the line as x-axis, the other edge as y-axis and the other edge as z-axis and call the names A, B, C, E, F, G and H. Now with this convention of treating D as origin, we can give names to each of the points, right? When the vertex D is taken as origin and the length of each side is 1 unit, how will be the coordinates of the vertex A? Yes, A will have the coordinates 1, 0, 0. Similarly, how will be the coordinates of the vertex C? That's a point on y-axis at a distance 1 unit. So it should be 0, 1, 0. And similarly, we can identify the vertex H, which is along z-axis at a distance 1 unit from origin. So its coordinates would be 0, 0, 1. Right? Now if you look at the point B, which is on the xy plane, and each of the perpendiculars from origin to that plane passing through B is 1 unit, how will be the coordinates of the point B? Yes, they will be 1, 1 and 0 because it's a point on xy plane. Similarly, the point G, which is on yz plane, will be having coordinates x coordinate 0, 1 and 1. Now similarly, the point E, which is on xz plane, then its coordinates would be y coordinate 0, so it would be 1, 0, 1, right? And the point F will have the coordinates 1, 1, 1. Now let's go back to the given data. What are these 2 points P and Q? They are the midpoints of EF and FG. So how will be the coordinates of the point P now? P, which is the midpoint of EF, will have the coordinates 1 plus 1 by 2, that is 1, 0 plus 1 by 2, that is 1 by 2, and 1 plus 1 by 2, that is 1. So we got the coordinates of P. Similarly, what is this point Q? Q is the midpoint of FG. We have the coordinates of F as well as G. Then how will be the coordinates of this point? 0 plus 1 by 2, that is 1 by 2. 1 plus 1 by 2, that is 1. 1 plus 1 by 2, that is 1. So we got the coordinates of Q also. Now what do we require? We need the distance of D, that is origin, from the plane passing through P, which is the midpoint of EF, and Q, which is the midpoint of GF. So the plane which passes through B, Q and P, this triangular plane's distance from origin is the requirement. So before we proceed to find the distance of D from this plane, what we need is the equation of the plane passing through P, B and Q, right? How do we get the equation of the plane passing through P, B, Q? First we can find the DRs of the line PB, as we know both the coordinates, right? So what are the DRs of the line joining P and B? That is the line joining 1, half and 1, 2, 1, 1 and 0. So that will be B minus P, that means 1 minus 1, 0, 1 minus half, half and 0 minus 1, that is minus 1. Similarly, how will be the DRs of another line on the plane, say QB? Yes, this will be the line joining the point Q with the point B. Now it is 1 minus half, that is half, 1 minus 1, that is 0, and 0 minus 1, that would be minus 1. Now we got the DRs of two lines on the plane PQB. Can we find the DRs of normal to the plane PBQ? Yes, we know two lines on the plane. So their cross product, DRs cross product, would give us the DRs of the normal to the plane. So how will it be? It would be I, J, K components wise, and position vectors of DRs of PB line, that is 0, half, minus 1, and the DRs of QB line, that is half, 0 minus 1. How much would be this? 2i plus 2j plus k. So what are the drs of the normal to the plane? This is what we calculated, PB cross QB. Then drs of the normal of plane PBQ is 2, 2 and 1. Now, knowing the normals dr, can we write the equation of the plane? Yes, we know the normals of the plane, and that plane is passing through any of these points P, Q or B. So the equation of the plane PBQ will be given by 2 times, let's consider the plane which is passing through point B. Then it is 2 times x minus x1 plus 2 times y minus y1 plus 1 times z minus z1 equal to 0, or the plane equation is 2x plus 2y plus z minus 2 minus 2, that is minus 4 equal to 0. Now we got the plane equation also, but what is the requirement? We need the distance of D, which is origin, from this plane now. Therefore, distance of D, which is treated as 0, 0, 0 from the plane 2x plus 2y plus z minus 4 equal to 0 is how much? Modulus of the constant, that is minus 4 by square root of 2 square plus 2 square plus 1, or simply it is 4 by 3 units. So what is the distance of the required point from origin? Yes, it is 4 by 3 units.